Today we're going to talk about how to convert between different molar quantities. For example, let's say you wanted to bake chocolate chip pancakes, and you look at the box. The mix tells you that to make 6 to 8 pancakes you need 1 cup of mix and 3/4 cup of water. If you want to adjust the amount of pancakes that you're making, you just have to adjust the mix and the water. Well, the same is true with chemistry. If we want to adjust the amount of something that we're going to make, some substance, we just have to adjust the amount of moles that we react. So in chemistry, to figure out the amount of anything that we need, we're going to look at these large numbers in front that we call coefficients. We've already talked about the fact that we call them coefficients in the balancing chapter. But here, the coefficients we're now going to call moles, and they represent the amount of moles that we need for a particular reaction to take place. So in this case, I need 2 moles of carbon monoxide, 1 mole of oxygen, in order to produce 2 moles of carbon dioxide. So here let's look at an equation. 2CO plus O2 gives us 2CO. We could figure out what we call the mole ratio. The mole ratio is just telling us how many moles we have of one quantity as compared to another quantity. So if we look at this particular example, they're saying what's the mole ratio of CO gas to CO2 gas. So we have to find CO gas, we have 2 moles, and then we find our CO2 gas, we have 2 moles. So the mole ratio of CO would be 2, to the mole ratio of CO2 would be 2. 2 to 2 would be the same thing as saying a 1-to-1 ratio. In this example, they're asking us what's the mole ratio of H to HF. So you find H in the equation. There's no number there, so remember when there's no number, we just assume that it's 1. To HF, there are 2 of them, so the mole ratio would be 1 to 2. Okay, so here's what we're going to do. Now we're going to apply the concept of mole ratios, like we know how many moles of one substance is needed to produce another, and then see, well, what if we change the amount of moles? How many moles would be required or produced? So in this balanced equation, we could see here, we have 2 moles of carbon, 3 moles of hydrogen, and here there's no number, so we can say 1 mole of ethane C2H6. The question is asking us what's the number of moles of carbon that must react to produce 2 moles of C2H6. We know from the equation that 2 moles of carbon are required to make 1 mole of C2H6. They're saying, well, what if we wanted to make 2 moles of C2H6? What if we want to make 2 of this thing, C2H6? How many moles of carbon would we need? So we make a little proportion. Whatever it is that they're giving us here, the 2 moles of C2H6, you put that on top of wherever C2H6 appears in the balanced equation. And we're trying to find the number of moles of carbon, so we have a little proportion here. X moles of carbon over 2 moles of carbon equals 2 over 1. We get to do our favorite thing in the world now. We get to cross multiply. So 2 times 2 is 4 equals X. So we have 4 moles of carbon are needed. Next question asks us, what's the number of moles of oxygen that must react completely with 5 moles of C4H10? So again, what I need you to do is I need you to underline what's given in the problem, and I need you to underline what it is that we need to find. So it says, what is the number of moles of oxygen? And what we're given is 5 moles of C4H10. So X moles of oxygen, and we're given 5 moles of C4H10. So our moles have to match here, so moles of oxygen and moles of C4H10. This piece down here is going to come from the balanced equation. So let's look at the equation. We have 13 moles of oxygen, and we have 2 moles of C4H10. So again, what we're going to do here is cross multiply. So, and we wind up that X is equal to 32.5 moles of oxygen. When I like to solve these in class, you'll see that this is one way of setting it up, this proportion method that I have. We also will sometimes just write the number right above it. So for example, I have 5 moles of C4 C4H10. So I'm going to go right above C4H10 and write a 5. And it says, what's the number of moles of oxygen? So right above oxygen, write an X. So this becomes my proportion. 5 over 2 equals X over 13. It's a little bit quicker. In this next question, they want to know what's the number of moles of water needed to make 2.5 moles of glucose. So 2 ways of doing this again. We could start, as I like to every problem, of looking at underlining what is given. So what is the number of moles of water? And given is the 2.5 moles of C6H12O6. So we make our little proportion, X moles of water, and 2.5 moles of glucose. And then the rest of the information always comes from this balanced equation. So we have 6 moles of water, and we have 1 mole of glucose. And then cross multiply. So you're just doing 6 times 2.5, and we get 15 moles of water as our final answer. You could, however, also just put them right over the number. So we have 2.5 moles of C6H12O6, and we want to know what's the number of moles of water, so go to water. So again, our proportion becomes X over 6 equals 2.5 over 1 as another way of doing this.